be fine. Nice. So that's that. Zoom. Let's get my video up. Good camera. Let's get my video up. Something's taking my video. All right, let's see if you guys hearing me. Okay, excellent. So, all right, thanks. So guys are hearing me in Zoom. I'm recording OBS streaming as well. Unfortunately, I wouldn't be able to pull the link because of the amount of Windows hoops I have to jump through to get the link to post it up. So for those, because if for anybody who have subscribed, they should get a notice on my channel that it went public. So you could copy that link and paste it in, right? So I can't paste it in the Zoom chat. So I will let you guys check it online. Okay, so first things first, yeah, I got the memo. I did not remind myself about it, but from today to Saturday, they want to do online. Class should be online to cater for graduation happening, and they don't want to minimize as much traffic coming on the campus. But I didn't put any notice for that for today. So I thank you all for being in present. Have the attendance sheet here. There are others who are online, so they are kind of going in a hybrid mode today. Now, I asked the class reps to put out a poll. I don't know if you guys got it. To have the coursework exam on Saturday, it's recommended to move it to the next week, right? Because of exams. So the question is, the poll is going out. You guys go and answer and stuff. I'm going at simple majority. So if it's 35 out of the 65 say yes to move it, I will move it. All right, and once I confirm, I get a poll hopefully today, tomorrow, I will send out a notice and I will email all students about it. Right, so just to message the class rep. No need. I already start and already sharing screens, so pretty good. They will join on Zoom to see the presentation online. So that's true. Yeah, if you set up the audio, the video, I go have to do a whole reshare screen and stuff. Yeah, but that's okay. Technically we're supposed to be online, but I'm doing a hybrid. Right? Yeah, I will. It'll be problematic. Yeah, I'm good. Thanks. Next week as usual. Yes. Thanks. All right. So some student posted up and I posted up on OBS on the YouTube stream. So you guys take a look at the stream, or you can look at the Zoom as well. Okay. So we'll see what happens with the poll for Saturday. I'm hoping by the end of today or tomorrow I'm going to get the results, and by Friday, during the course of Friday, I will put out a notice, let everybody know what's happening. Hopefully, it will be pushed to the next week, right? And not come out on Saturday and deal with graduation, traffic, and all those things. Even though in the lab here, traffic flow would be less, because if you come early, in between graduation time. Once you come, you could have a trouble. We'll see. I'm hoping you guys put your polls on answer, right? Okay, so let's move on. So today we're gonna do with RIP. Before I continue coursework exam stuff, other than moving on for the next week, how you guys are studying for this? Good? Some of you, a lot of you are answering already, did through the sample quiz. Those who didn't, just block off a time. It's 90 minutes. Just take it in the evening. Just click and go through it. At least get an idea of what you know and don't know, right? If you don't know, just click through and see what you get, right? For those who do, great. I got some results. Some of you doing well, but then that quiz is kind of easy. It's not a hard quiz per se, but the actual coursework exam kind of be based on that. The questions will be more detailed in some areas. You'll get some repeat questions in the quiz. So if you did it, you might get some easy answers, and you just go ahead and you should answer fine, right? The time frame will be an hour and a half. No backward navigation. I would have posted up the quiz information so you guys could see it on the page about what you need to do. Yes, you'll have to bring in your pen and pencil to write, do your calculations, and then any subnetting to do. It's not using the calculator, you're not using the web browser. I will be, because it's on person, I will be patrolling the lab to make sure you guys not going on any browser and stuff like that to get the calculator. Plus, you might waste too much time doing that anyhow, because the computer's not, some of them are fast, some are not. Right? So that's what it is. It's set up to be like the Cisco exam. That's why I want to have the exam in person, so that you don't have to, so you get the closer to what the Cisco is, as opposed to taking this exam online and at home or whatever it is. Because then you have collaboration, you can go online, and I don't want to force this exam browser thing on your machine, because that could cause trouble on your desktop, right? So that's why it's not good tested. I know we had issues with sometimes you test and it doesn't work out too well. So that's why I don't want to enforce that there. Maybe in the lab later on, but then you had to come in lab in person, right? So that's where you have that limitation. That's why I don't want to have it just online as well, right? I mean, at any time. Maybe soon later, I'll see. Next time. Right, so that's what it is with the coursework. One, group project. You guys are going along with the group project. I know you have other courses to work with, so you have to pace yourself. I did not ask you to create your own groups. I mean, I asked you to create a group. I didn't ask you to start to schedule your meetings, but you should really start to collaborate. Have your WhatsApp group for it if you have to, Discord or whatever it is, and then start putting information together. Use your Google Drive or OneDrive, UV OneDrive, your student OneDrive, to share your documents. Have your Word document with everything, and you start putting in information in there, right? Because as you enter, you could then fill out the table. Somebody could use that and then add it onto the GNS tree. I post up 2 stuff on GNS tree for the group project. You can increase the size of the GNS tree scene view to cater for the entire group project size. So if it's really large, all the devices, I recommend that 20,000 by 20,000 pixel size, so you can actually scroll to all the full size of the window. The GNS tree had a limitation where the window size was small and you could not scroll beyond, because it just chop it off and that's it. You could zoom out, but when you zoom in, you can't scroll. But with the pixel size, scene size, I don't know how we didn't figure that one out, but nobody said anything online. Once you do that, you can scroll all the way to the left or right or all over and zoom into your project and see what it looks like, because the pixel window is much larger. So that's what GNS tree and the application. 1, 2. I also created a procedure, because it is not online, where there's none online showing you how to set up your GNS tree as a web server. There is a web server feature. You install the web server, and then how to connect to a project, and how to connect it through a web browser, and also share that with other persons. So once you're on a LAN or local area network with your colleagues, use your phone as a hotspot if you want to. Everybody connect to your hotspot. You're on a local network, a wireless network with your hotspot, and you can actually change the IP address. And I do that in the procedure to an IP or what you have on the hotspot, and you let everybody connect to that IP with a certain port, and they access your GNS tree project on the web browser. So, and then they can make changes to it if they want to, move across diagrams, add stuff, all of that done. So when you're collaborating in a hotspot network, that's fine. But if you want to do stuff outside, and let's say you want to do port forwarding, I leave that up to you guys to figure that one out. where you set up port forwarding on your home router. So you set up your GNS3 web server at home. You set the IP address of it to use your home IP address. That should not change. Use the HTTP or whatever, set a static IP or what. And you do a port forwarding of a range of ports. And I put the list of it in this procedure. The port forward from your router or your modem router to that PC with those range of ports. And what happens is that you have your colleagues or your student group members connect to that public IP and hit that port IP and port number, depending on your port forwarding works. And they should get you access to your GNS3 project from online, anywhere, anywhere, right? So that, well, of course, your machine computer had to be run at home. So it's based on a desktop. So that's how you can connect, and everybody can connect online. So I am not going to demonstrate into detail. I just showed you how to set it up so you can do a hotspot and everybody can connect to your hotspot wherever you move to with that project, right? So I put that in one of the threads in the forum, in the group project forum. So that's how you can share your project with others or your members of your group, and then they can edit at the same time. Recommend you do that because you're going to start adding devices and put IP addresses on it, right? So you're going to be sharing a Word document with all the information, and then you're sharing your GNS3 project so more people can edit at the same time. Saves on time, especially with the amount of configurations you have to do, right? Other than the IP addressing, my recommendation is to really start to build your devices to look like what it is in the diagrams. Once you have that set up and you make your connections, then you can start plugging in the IP addresses and then start testing from there, right? So once you have what it looks like, it's easy for you to start adding in your configurations in it, right? So that is really the GNS3 plan. In the real world, if you're doing any, in the real world, if you're doing that configuration on the real world network, because you pre-plan it before, you will know what connections your device will have, and you will configure the device in lab or in your environment, working environment first. Your testing, your deployment environment or your staging environment. You configure the devices, and then you take it and then send it out to the environment, to the actual location, on location, and then they connect. Do a test, and then that's it. So that's how we would do it in a real world deployment scenario. But in the GNS3 to save on time, you just put the devices, deploy them out, and then you configure, because configuring is easy. Double click, make your changes, right? As opposed to real world, you can't just go and double click. You have to actually go to the site because the device is not connected to the network yet. You have to go on the site and then make your changes, right? So that's where there's difference between real world and GNS3. So your techniques in GNS3 will be different from techniques in real world, right? Right. So I will right, send that back out. Okay, great. Okay, so what we're gonna do, we're gonna get into RIP. Now this is a long slides, even though it's just one, but I didn't split it up. It's gonna just be one set. It's only one lecture, so you guys are gonna have to read the rest. If we move our exam to next week, then the lab on Saturday, we'll have a lab on Saturday, means that it'll be online, right? So you don't have to come into the lab. I'll make an announcement, say it'll be online, right? And we will just have a lab. So we're moving on. Ooh, right. So this is the first case. So those who have had experience when we did the other labs, when we set up IP routing and stuff, especially the IP routing lab, which most of you we have not. I think we have done a lab on it. And then we had the VLAN routing as well. So with the IP routing, we actually had two routers. And we had the networks on the left, the IT network, well, on my right, your left. And then you have the accounts and marketing network on the other side. And we had two routers, and we had to set up the routes in between so that the packets could go across and then come back. And we were doing the ping operations and stuff like that, right? So that is the case of the static routing. The problem is that we have to now plan ahead what we're going to do. So in our case, that was just two routers. That was easy to work with. But what if our network starts to grow and we have more routers, and then we started to add more networks to it? Then it becomes more complicated. There's not no one single router that you're actually going to be just, and that is what we did in our campus network. We just have one router, which does the core is doing all the routing right now. We kind of moving it away from that now to do routes into the firewall. But at the end of the day, that's what we have. So it was easy because it's just one device to configure or two devices to configure. But the real world, and that's where your group project 3, 4, and so forth, you're going to be using 3-tier diagram where your routers are actually on the perimeter before your edge. So you have a 3-layer, core, distribution, and an access. Your distribution is where your routing is going to happen. Your core would not have any routing per se. It just fast forwarding and more span and tree and ether channels being set up between the core and the devices going out. And then your distribution is going to be doing all your routing there. So that's what your group projects will be dealing with, right, for those other groups. But the thing is, you have to know when you're doing all of that routes, setting it manually, statically is going to take a lot of work, and we want to move away from that. So this is where the whole concept of dynamic routing protocols is coming in, saying, hey, is it a better way that we can learn these routes and then add it on the router, right? So in most cases, of course, we have one router in your home network. Where's my good? Right, mostly one router. But what we want to do, we want to end up adding more than one. We have to set up more static routes. And the problem is that if your route changes, network changes and stuff like that, you're going to end up have to reconfigure static routes. And it's going to be tedious. And then you can make mistakes. Remember, I showed you how Huawei has a different administrative distance for static routes. They make it a bigger value than OSPF or the dynamic routing because they don't trust the admins to make the correct change. And it does happen. As a matter of fact, guys, you know about the Amazon Web Services problem happened on Monday, right? So, yeah, so that was this a DNS issue. There was a Facebook problem some years ago, and that was a routing issue, and that was a BGP routing issue, and that was a mistake made by people on the internet who have access to BGP servers. They make a mistake. It wasn't and they had checks, but they had to have more checks. The problem was that was a mistake they made, and then the routing protocol learned the mistake and then propagated across everywhere. It did what it had to do, and that is what you trust the routing protocol do its job. It did its job. What you did is that you, quote unquote, you could say, give it a poison route, and it propagated that poison route out, and that's what ended up happening. There was a problem years before with something called there was a DNS, not DNS, a whole black hole network set up, well, with YouTube, where one country set up wanted to ban YouTube from their country, and they end up setting up BGP routes to redirect YouTube away. Unfortunately, it ended up becoming where they became the destination to go to YouTube. So the rest of the world saying, okay, I want to get to YouTube because they are an ISP in the country, and they set up and say, okay, we don't want YouTube to come to us, but they set up some misconfigured default gateways and say, okay, all the YouTube networks point to this location, which was literally on their ISP. So in country, everybody hitting YouTube wasn't getting access to it, which was fine. They were happy. But the rest of that propagated to the rest of the world. And now the rest of the world saying, hey, to get to youtube.com and this block of IPs, go to this country ISP. So everybody in the world who hit on youtube.com was going straight to that ISP. And it was just literally a denial of service attack happening there because everybody in the world in YouTube is getting error, can't find the site 404 kind of thing, page not existing, server's not there, but they keep hitting it. And they literally brought the ISP. For that country, the ISP went down. They could not handle it in terms of the amount of traffic coming to it. So when Google saw that problem, they had to then make changes in the BGP to kind of unpoison certain routes to force back YouTube to be pointing back to the YouTube servers. So because of how the ISP is set, I think what they do, I don't know, you're going to have to read about it. So what you can do is search for YouTube black hole or something like that, and you can find that. That's like 2016, some years ago, but it didn't matter. It happened before, happened again, and happening again. So a lot of these mistakes are happening, and it's propagating. The rest of the protocols are propagated. Doing what it does. Nothing is different from what we're doing here. OSPF, EIGRP. You make a mistake, the mistakes are propagated. You may think you're getting through with it, but it's maybe not be optimized. You may have gotten your network, but the traffic may have to go through some extra routes or extra router just to get where it has to go. So it may not have been optimized. So that's the thing about dynamic routing protocol. So that having an idea how it works, but trusting that it does the job, but make sure you also give it the right information to get the right information, right? Where is the next? Right. Yeah, I hate this. Right, this is Zoom is doing this for me. Hold on, guys, just now. Okay, so Zoom is messing up with my thing here. I need to remove the annotation. All right, there it is. Clear everything. Right, much better. Okay, good. Right, so components of the routing table, which we have done before, we have prefix, right, slash 24, 16s, 32s, slash 25s and stuff. You have prefix to learn, you have network mask, which will work hand in hand with prefix. You have the next hop, which is important. Route, and remember, that's why you did static routing, to know how to build your next hop. And then once you know how it works, then you route the dynamic routing protocol is create those next hops for you. So once you understand static, dynamic is going to work for you just much more, right? When you build out your network in a group project, it's going to be like about maybe 2 pages of routing entries in your router. So you have to know that. Protocol code, administrative distance metric, gateway of last resort. So we did a gateway of last resort, or default quad 0, right? IPv6 has one as well. We know we did metric as well, and then we kind of played with it and say, hey, you know what? To get to this network, use this metric. But if you want to get to a similar, smaller network or just a specific PC, you use a host route, and then you give a different metric so that once you hit that, it goes there first, right? Routing, right, different routing information sources. When you're doing this in a group project, you're going to see this happening. Well, sorry, I can't point because I'm on this. So I hope you guys checking this online, right? YouTube, phone, Zoom, right? Connect to Zoom and you could check it. Just mute so I wouldn't get feedback coming in. Right, so you have the administrative distance is going to be used to determine which routing protocol will be the preferred one. Now, when you do your setup in a group project, you're going to have multiple routing protocols. You're going to use all three. Most or all group projects will be using all three. So you will be seeing routing protocols, and most routers will show them. Some may show all routes. Others will just show what you call a summarized route or something like that, because we're going to do something called route redistribution, and that's part of the group project. Post up your questions in the forum, we'll go through that process, right? To fix that. Not fix it, but to configure it and get it to work. So administrative distance is going to say, okay, this is the routing protocol priority we'll use over the others. So RIP will be like lower priority than OSPF. OSPF is lower priority than EIGRP. And that's the order it will happen. So it'll learn, if you have multiple routes, it's going to pick EIGRP first. Now, when you configure it correctly, you don't have to worry much about it. The routing protocols will do the work for you. You just have to look at it. It's only when you're troubleshooting, then you're going to see why this is happening, why it's not happening. So I'm hoping that you don't have to go to a troubleshooting level, because it's more headache, and sometimes you may have to rethink your routing table, and you may have to do some reconfiguration, right? You may have to clear the routing information configuration and then do it over. It's pretty straightforward when we start to do it, right? Static and dynamic, going to do that, and then we're going to configure, verify version 2. Of course, you have things like, we're not doing authentication on stuff like that. We will be doing the redistribution in the group projects, but not really teaching it here. So you'll have to, I did put Cisco content online, so you guys should go to those pages and take a look and see how to do route redistribution, right? So they have examples how to do it. Right, so just forget this. How am I for time? Yeah, let's forget this, and let's go to the next one. So we'll deal with that later. Come out of that. Right. Well, the slides. Right. So routing protocol right? Essentially, because it's routers, this is layer 2 and layer 3, right? Routers and layer 3 switches, right? They learn routing information about subnets from other neighboring routers. That's how it's going to work, which means the router has to communicate with one another, and because of communication going to happen, most times the communication is done at the layer 3 or the IP level, means things with making sure the right subnets are set up. That's what your whole IP address table is going to be built out. And that's what we're going to do in the labs. We'll show you the table and follow those things for your group project. You're going to do a group project well in terms of building out your proper subnets, right? Not only that, the routers advertise the IP subnets, the IP routing information about other IP subnets along that to other neighboring routers. So basically, one router is going to learn and send out information to the other routers, right? And it's only on the immediate neighbor. Routers along the way don't have to know about the other neighbors. They don't have to communicate with them directly. They use what they learn about others and then pass that information along, right? You guys know about some of the games they play, right? You know, you pass on a message, or the message passing, you have a line of people, and you pass the message on along the way, and eventually ask what they say at the end, and the message got lost in translation, as they say. Routers don't do that because the information is digital. It's the same as they go along, and the protocol and the concepts work, right? Now, if we're doing a message, let's do this. Let's be doing a chain of persons and we're passing the message along. We sometimes, for humans, because of the audio, and we may mistake it, what we could do is we could do a TCP style protocol, right? When we do a message and say, okay, I'm going to pass on the message to you. You acknowledge you receive, but you're going to tell me back what the message is. And then I will confirm that is correct, yes or no, what I'm hearing. There are two ways that can happen. What I'm telling you, you misinterpret what I'm saying, and then vice versa, right? But then I repeat the process. So back and forth until we get the information correct. So if you apply a TCP IP handshaking to make sure that your message that you receive from the person is correct, you can indefinitely pass that message along the way for another person and they get the right information. Now, routing protocols, updates, don't have to worry about that. Information is digital, is fixed. It's not going to be lost unless the data, the update package frame is corrupted. And if it gets corrupted, they will do their checks, just like TCP, and say, well, you know, this is missing something, the checksum is wrong, please resend. Or I wouldn't worry about it. I'll wait for an update to come out, and I will ignore the last one because it corrupted, and I'll wait for an update. And that's what we're going to look later on. So they don't have to ask, say, I didn't get what you hear, send it over. So in your chain of persons along the way, you're going to you literally can actually send the same message again and again to the person, and they just can relay it along. And that's how it can happen. That's how it works. So you notice that if you keep doing that, there's a high chance that the person on the end, if it's a line of 10 people, 100 people, will most likely get the right information at the end. If it gets corrupted along the way, you're going to keep sending the same message over and over until you realize, oh yes, it's not supposed to be this corrupted information, wrong word, it's this instead. And they keep going like that. So you can actually simulate how routing work with persons, right? So that's one way. That's message passing. Updates are going along the line. The next one, number 3 in this list. So if a router learns of more than one route to reach its subnet, right, it's going to calculate the best route based on the routing concept of a metric. So one is metrics, different for administrative distance. We kind of dealt with metrics with static routes, and you have a value at the end. So that's like a metric you put in there to force it and say, okay, this is a better value than the others. A higher value is not good. As a higher value means as a metric is not good. Right? So lower value metric is what you want preferred. Right? So when we did talk about floating static routes, and that's the example where we have a T1 line and a gigabit line. So T1 is low and then you have the gigabit, but the T1 is a static route, lower value, and OSPF. So you had to force it and say, okay, let's put it a higher metric so that if anybody learns anything, they'll use the OSPF first. Should the OSPF shut down, then the one with the higher metric is then going to be seen, hey, that's the only one, and then I will use that. Right? So that's the way of using the metric. So they're going to use metrics to calculate the best way to get to that client or the router, to that network for that matter. And they're going to put that around the table. Now, you may have, when we go into other dynamic routing protocols, could end up having, because we're going to have multiple, and you're going to see it in the labs, you're going to see like 2 or 3 routers, especially the OSPF. You're going to have like 4 or 5 routers, and there's more than one way to get to that network because they could pass through 2 or 3 routers. But what's going to happen is that we're going to demonstrate that, hey, you can go to it more than one way. We're going to keep the information there, but we wouldn't use it because the metric is much bigger value. It's not preferred. But should a link fail, it's going to say, well, you know what? This is the more preferred one because I cannot get going through the normal way, right? So that's where the dynamic routing will happen. And you don't have to touch it. The system will do the balancing for you. When you do your group project, you can see that happening as well. The group ones and the group twos. No, the group ones and the twos, yes. No, not the group ones so much. Group ones, not so much. The group, I think one of the groups, 1 or 2, you're going to have a whole ring of routers. You may not see it. Everybody free to view what other groups have. That's posted up. So you can actually go to everybody group forum and see what somebody else has posted, what project they have received, right? So you can view whatever others have gotten. So there's one where there's a ring of routers, and in that ring, there's actually connections going up and down. And there may be one, there's not much side to side. So how is that set up is that there's multiple ways to get to a network. You can either go along the ring and get to there, or they can cut across, straight across, right? So the advantage is that most people just cut across and they will do that. Or there may be a place where cutting across might work, but just going along the ring will be the better way. The dynamic routing protocol will determine which one. And when we go and do that demonstration when they present, we will demo it. I will tell you, shut down an interface and let's see how the flow of the traffic goes, right? Because when you do your trace route, it'll go through a part. And I say, okay, see that router tracing going through? We shut down that link there. And it's going to see it recalculate and go through another route, right? So that's the advantage, and it helps with redundancy. So I find that is a nice group project because it's showing you how to get to one network through multiple locations. It really is a good way. It's the project came out from they wanted to do a surveillance network of the country, a country surveillance network, and they wanted to have cameras accessible. So if one router goes down, the system will reroute and go to that other router. So it kind of keeps the uptime of the surveillance network countrywide. So that's something with national security get involved and so forth and so forth. But it doesn't matter. You take the idea and assimilate it, right? Each router can be a different location. How the connections are made, I don't know. Where it is run, I don't know. That's a national security thing, but that's a logical design. So where it's physically happening, well, that's up to the vendors and country and national security to do that, right? But the concept is there. That might not be it. I just make that up. It's not really, when I hear about saying, okay, they want to do this, I say, okay, well, these are the routers. This is how we do it. So that's learns more than one route, and then they have multiple routing protocols. So you're going to have router redistribution happening. So some of them are going to be RIP, some are going to be OSPF, and there's a case with that design is splitting in half. One side is EIGRP, one side is OSPF, upper side is RIP. And then other groups will have it just swapped around. So in the end, there's a lot of things that are different. Even though the design is the same, your commands are going to be similar, but the actual network address is going to be different because we're going to use your student ID numbers to create your networks. So even though we change in RIP and OSPF is changing, or EIGRP, your student ID is going to be different as well. So there are 2 variations happening there. That's why I'm telling you, please collaborate with the other group members who are doing the same thing. Because the idea is to get the concept down working. Yes, you plug in your network address, but at least they'll tell you, well, it worked for me this way. Maybe you could try that way. And then the idea is that your project, you guys could work on it and get it working. If it worked for you, then you say, yes, it worked. So you kind of learn the concept, read about it, you learn it, and you kind of reinforce your learning how to get that concept working. So that's the purpose of collaborating. And that's why the group projects are the same or similar, some variations. Right, that's why I said you could collaborate, everybody collaborate, everybody. Could happen. But you need to, you have to do the work, means your 4 members have to do the work, right? Next part, react to changes when the network topology changes. So when example, when a link fails, as I would demonstrate in the labs, and your group project will demonstrate it, which is pretty cool. A link fails, it will find a new path to get to that network. There will be a point in the lab where we fail enough links that the network then becomes unreachable. And all the essence and some purposes, yes, that's what happened here. You cut all the links. And let me tell you, that is what the internet was designed for in the first place. Years ago with DARPA and all these guys. Remember the internet came from defense research out of Los Alamos Laboratory and all these guys in the military. They wanted to redundant links between sites so that if one fails, it got destroyed by a nuclear, and that was during post World War II and stuff during that time. That's why they built that. They made those things to why, and then that became more popular. So remember, the military still have their own internal. We don't know that. But they have the internet as the public one. All right. So they have their own. But the internet is that if a link fails or something gets destroyed or somebody sabotage a link, then they actually the system will detect and reroute. Now, what happened with the Facebook problem years ago? That was WhatsApp, Facebook. That's a Facebook issue. It was a routing issue. So that showed how easy it was to cripple the network because it was a mistake. But attackers can use that as a way to cripple the network. So now they had to put something in more robust to figure out how to stop that from happening. So what they do is they can literally poison the routes. We talk about route poisoning here, but they're going to find ways to intentionally poison it and put invalid route information to force routers to relearn and do something else, right? And repoint traffic somewhere else. So that's the problem right now we have. As you can see with the Amazon Web Services with DNS. And as we have DNS security, I'm sure they have DNSSEC running. So DNS was an issue and we had a problem. So it wasn't an attack. It was a mistake of something happened there. But people can use that to say, okay, DNSSEC is secure. You have your encryption, you have your certificates, trusted servers. No, we're not attacking that, We're going to see how that failed this Monday gone. And we're going to try to find a way to break and get into that part of it that caused that to happen. So if they have to be on site, they will look for insecure site and go there and attack that site. That's what they will do if they want to repeat that problem or try to do an attack. So just remember, hackers are just watching everything, right? Right, so that's what's happening with routing protocols, what they do with the four stuff. I wouldn't go too much into the history of gateway protocols. This next slide here, where the timeline for the interior gateway protocols are IGPs. So we're not going to worry about that. You can see how far back it went. RIP was the first one, 1980s. Then OSP, then IGRP, which is Cisco, and then the others came on board. We're going to do most of these. Eventually, RIP might end up becoming deprecated, quote unquote, these words, deprecated, not being used anymore because OSPF is becoming the popular routing protocol. It's open, other devices can use it. Even EIGRP is not being used much more, even in Cisco. Even though Cisco opened it up for EIGRP, they opened it up for other vendors to use, but because it's Cisco, the OSPF became the more popular one. Now, personally, I like EIGRP because of how it's designed. It's nice. It can handle stuff without the area issues, but at the end of the day, OSPF kind of becoming the popular one to use. I rather EIGRP, much easier. And you can separate EIGRP areas as well. Something when we do the OSPF labs, and then I'll do the EIGRP lab, we'll see how it works there. Right, just comparing the gateway protocols, interior. These are for inside one company organization. And then you have the EGP exterior. These are between the internet service providers and the internet. Now, IGP is what we're using for this course, all the way down to the end. For the WAN course, we're using the EGP, and this popular one is called BGP or Border Gateway Protocol. Now, this is the interesting thing. The problem with the Facebook problem and WhatsApp that happened years ago, it was BGP they were using, and the BGP, even though it was trusted between the sites, there was an engineer problem, or let's call it an ID10T. Look at that. So you guys know about ID10T, right? Okay. Write it down and you'll figure it out. There's another one called PBAC, and they have others, right? But the point is, that was a PBAC or ID10T problem where the engineer made a mistake there, and that the software and the propagating around, right? The software is trusted. It's just like okay, we can call it the weak link. It's just like you have everything all nice and encrypted. Okay, a good example. I'll do a scenario because it's nice to give a scenario with it. You guys know about BitLocker, right? And encrypted disk. Right now, Windows 11 or buy a Windows 11 PC, literally it might be out of the box encrypted. Or booting up using TPM. Just a little tip, I might help it on the website. If you guys check and see if your device is BitLocker encrypted or booting off, right? I recommend you go and print the BitLocker recovery key and put that in a safe space right now if you can, right? Why? I just read an article this morning. Somebody reinstalled Windows. They did not realize that the BitLocker was already encrypted. When you reinstall and say, where's your recovery key to unmount your 2 terabyte or 3 terabyte drive? Now, these externals or extra SSDs that were in their machine, and they could not recover because it's BitLocker encrypted. It's a 128-bit too. It doesn't matter to break that. You'll need some quantum computers to deal with that. So either they keep that safe and wait till the technology is ready for them to break that, or they consider that has gone and wipe it and use it back for something else. If they had the recovery key printed, they could have been able to recover that data. Right? So just remember your Windows 11, Microsoft do nothing. Not their fault. They're securing it. That's great. Means that somebody cannot just pull out your SSD, plug it in the machine, and then get your data. Right? I want to say about this one. So BitLocker encrypted, print out your recovery key. Right? Do that if you can. I'll put that on my notice. I'll have it didn't have it. No, they had it for the C drive, but they didn't have it for the other drives. The recovery key. Yeah. Let's say sign in, so they sign in Microsoft account. Looking like it, there, but they didn't realize the others would, because the keys weren't there for the others, the person thought the others weren't encrypted, BitLocker encrypted. And that is the problem. Sometimes missing information means that does not mean that it's not there. To say that the encryption is happening. So that's, you see, I remember you guys in IT, yeah? Most people don't know about this. This person has extra drives for backups. They know what they're doing, and look what ended up happening. So it'll happen to the best of us, and it'll be worse for the worst of us, right? But I just let you know that's what happened. So that's one side. Sorry to digress, going back. So what happened? Weak link. Somebody uses BitLocker, others use something called TrueCrypt. Now it's VeriCrypt. That is an independent encryption technology to encrypt this really cool stuff. Read about it. Really nice, separate from BitLocker. Other than there's something called I think pretty good private PGP is another one, encryption disk. So everybody doing it now, Linux and all. The thing about it is that an attacker compromised someone's machine, but because the data was encrypted or the disk was not encrypted, they couldn't get access to the information. But what they did, the person did not know that the machine was compromised. What the attacker did was wait for this person to mount the encrypted drive as a drive letter, because they will have asked for a token, a password, a file, and it doesn't matter. Once that is mounted in the system, the OS is seeing it as an unencrypted drive letter. The attacker now has user space access. They say, well, okay, now I see this drive mounted. I can have access to your data, encrypted or not, because you already decrypt access to it. And that's how they got access to that person's data. They just waited for them to unmount the drive, right? So this is the problem with using drive encryption like that. You have to make sure your machine is not compromised. So that was a weak link. And it's the same thing with this BGP protocol. The weak link is not the protocol per se. It's whoever's making the changes can make a mistake or be influenced to make a mistake and then cause that to happen, right? So that's what they call you're hacking the wetware or influencing the wetware. The wetware is people, hardware, and then you have software, right? Hardware, software, wetware. It's reality. Once we are humans and we are flesh and bones, we are wetware. And we are part of the system. Even the matrix, yeah, part of hacking the wetware. Right. So these are the right. So right now it's still only comparing IGPs. RIP1 version 1, version 2. We're using RIP version 2. This is what we're going to follow. You have the ICND2. These are the in the slides. The ICND2 book talks about EIGRP, OSPF, and OSPF v3. So let me just write that down. ICND1 talks about RIP1, RIP2. This is the old Cisco stuff. The new Cisco content 2019, 2016, 19, 20, 20, 25 would not have RIP anymore. So eventually this course, once I do a review, this content of route information protocol RIP will be removed, and we'll just stick with OSPF and EIGRP. I might more focus into IPv6 of these protocols. All right, next slide. That's right. Huh. I wonder if I should go into this stuff here, boy. Should I go into it? All right, I'll just do it quick, comparing IGPs. So the comparing it, there are two major types of interrogator routing protocols, which is the suite of RIP, and then you have OSPF, EIGRP. Those are the three main ones, right? They have others, but we're not covering those. So there are two types out of that, two categories. There's something called distance vector, DV, and then you have something called link state, right? Then you have the usefulness of the metric. So each routing protocol will have calculation of different metrics. So they use different metrics different ways. I think we're gonna deal with that just now. I think EIGRP uses OSPF uses cost, and EIGRP uses link speed and bandwidth and stuff like that. So that's what they use to build their metric. And the metric values are not like 5 and 10. It's in the hundreds of thousands, sometimes millions, because of the way how they do their calculations. I wouldn't get into that detail of how they do those calculations, right? So that's something you could look at, but I'm not going to get at that. The CCNA exam may not focus too much on it, but for you to identify where the administrative distance is or what the metric is, and that's basically it for the exam. The exam might only have 1 or 2 questions on that. So that's why I wouldn't want to dwell too much in it. Right, so the next thing about the metric is that the better the metric, in most cases, the better the metric is basically, the better means lower value in the metrics, the better one we'll use, right? So administrative distance is one, and then you have metric is the other one as well. So let's say the administrative distance is the same means the route and protocol might be the same. The metric now is the next value to use to determine which is the best route to take and stuff like that. Lower the value, the better. And it's just like static routing. When you do static routing, the administrative distance is more or less 1 for everybody. That's when you have an admin. That's for Cisco. It's 1 for everything. So if you do two static routes to the same location but at different distance, or you go to another router, which is the better one to choose? Both are equally the same because the administrative distance is same, and then your metric is the same by default out of the box. So that's why you would put one with a different metric, a higher value, which means that it would not be the best choice. It would be the one that you want, preferably. And then you could change it, make one the better one. You change the metric, right? So that's how metric will work. So administrative distance is same, metric will then be used as a determining factor. If the administrative distance is different, well, then you're looking at which one is the better one. The lower value administrative distance is the one you want. And that's what we're going to see. So the next thing with these routing protocols, you also have the speed of convergence. How long it takes for the routers to not just if there's a change in the network or an addition to the network. And most cases, when you say the word change, is the better word to use. Change could be an addition, deletion, a router got destroyed, a link goes down, a link comes up. All those are changes to your network, right? So that's why change is what you're looking at, and something called change management is the next story we want to get into in a more business process and stuff like that. But so when there's a change in network, the routers will have to send updates or use updates, or updates will be sent because of a change, and then they'll have to recalculate the best route. Sometimes the information might be too much of a change. Sometimes you have to do a whole lot of recalculations, right? Because let's say a main route in the center of everything is gone. Now everybody has to recalculate and use it. This is like the perimeter routers have to be used instead of the core one, right? So that changes a lot. Either way, it has to do calculations. And then once it finishes the calculations, it has to, and that's where part of the process is called convergence. When you do those calculations and you converge to a point where, okay, now I have something I can put on your routing table. So once I can get a point where I can converge and put on your routing table, that's the end result. Remember, if your routing table does not have the information, the router is not going to do anything. If it's nothing populated, and that's why you have to do your show IP route to see what's there. If it's not there, it didn't learn anything, it's not putting it on the table. It may have information, it's getting updates, but it's calculating, but it's not finding anything that it can do with it. And it cannot put that information on the routing table. So once it cannot converge and reach to and populate the routing table, then then you're not getting a solution to where you need to go, right? So that's what we could basically call a solution to your network, to your net destination. So the next thing is speed of convergence. Sometimes it takes a while. Other routing protocols, because of the size, it takes a while to converge because of a link change. Spanning tree, right? We did spanning tree. We show what happens when you take down a link. It has to, and this is really whole, when I had the diagram with the two cores on the top, and then I told it, hey, let's change the, who's the root bridge? And then everything changed, and everything started to orange, and it took a while for the orange to turn to green, and it took a while for some of the oranges to turn to green. All that is spanning tree doing convergence there. That's at the layer 2 level. So something similar is happening at the layer 3 level with the routing protocols, where it's learning where is the best part. So spanning trees are a nice way to learn on parts at layer 2. Not perfect because you can't put too much in there. You have about 7 hops down, and ideally. But routing protocols, you're going more. You're going like 5, 10, 50, here to the rest of the other side of the world. That is how much routing hops in between, right? So that's where the routing protocols can handle more of those things. And the convergence, they convert pretty fast. Some of them is a few seconds, not really minute. Spanning tree will take about 30 seconds, 90 seconds, a minute, too, depending. While dynamic routing protocols will be much less. But regardless of what, they will take time. There will be some time taken. There will be downtime. Traffic will be dropping. Imagine you have a gigabit of traffic flowing through a network. A router goes down. Yeah, your streaming might get paused. Or you decided to stream, I'm streaming out to YouTube, and a routing problem happened to YouTube. If it learns fast and the network is relearned, my streaming should continue. YouTube has about a 10-second to a 20-second buffer or something like that. They set it up so that if I'm disconnected for less than 10 seconds and I reconnect, it's going to continue. Just throw a disruption and continue. That's good. If I'm disconnected more than that, it's going to say stop the stream. So that's how they built that in there. You could set it for more, I think. But because the internet routers out there, they may take longer to learn because of how much routes in the world. Remember, this is internet routes that's learn. It's going to take longer. But the internal network might be a problem. Lose a router, few seconds and you're good. Your streaming is going to continue as normal. None the wiser, you're fine. So convergence time, and it's dependent on routing protocol. And of course, the next one is the properties of IGPs we're comparing, is if it's a public standard or vendor proprietary protocol. So RIP is a public standard, routing information protocol. OSPF is also a public standard. Other vendors can use it once they have something called RFCs, request for comments. That's what it is. And then of course, Cisco created their own proprietary protocol. And it worked really well. And they decided to kind of open source it to the other vendors. Not open source it, more like with a license, a free license per se. But it was too late. Vendors say, nah, I'm going to use that. I'm going to use OSPF. And that's what ended up happening. Plus, yeah, that's what ended up happening. So it's until 2013 it was private, but now they opened it up and it didn't matter. Even now, EIGRP is now being removed out of the Cisco CCNA syllabus as well. Right? So there's stuff that they opened didn't work. So it was too late. That's a little more than 10 years ago. Time flies. Right. So you have something with how they work out metrics. So for the case of RIP, so the next slide here, we compare the IGPs. For time away. Right. Okay, guys. So I may have to stop here now because we're hitting the hour. Right. So comparing IGPs, I'm going to look at RIP hop count. The metric for RIP is hop counts. How much hops it has to go to reach to the other side. That's how it uses as a metric. While other protocols use cost, some use bandwidth to calculate where it is the best place to get to. Right. And when you look at the slides, you're going to see that. Will depending on your poll that's going out. So you see the email, right? You already got responses? Or everybody or most? About 50? All right, just need to get my screenshot so I'll know how much it is, right? So I'll get a response. I guess we're going to be going next week, right? All right, cool. So by later tonight, I'll do an announcement based on the polls that we could push the coursework exam to next week, Saturday. And this Saturday will be online lab. All right, so it'll be this RIP lab. I'll be doing that online, right? So we'll see how it goes from there, right? All right, attendance sheet is passing around, so you guys go ahead and sign up. I also took stuff from online for hybrid, right? Guys, thank you very much for coming. I'll see you guys online on Saturday. All right, nice. Enjoy. All right. All right. Thank you.